Okay, hi guys. So today we'll be solving Leetcode problem. Longest happy string. So a string is called happy if it satisfies the following condition. Only contain the letters A, B, and C. It does not contain any of AAA, BBB, or CCC as a substring. Means a word cannot appear 3 times in a row, right? So it can contain at most a occurrence of the letter A. Same for B and C, right? So we are given 3 integers A, B, and C. We need to return the longest possible happy string. So let's take a look at this example, okay? So we're given A equal to 1, B 1, and C 7. Now let's say what is the output, right? CC A, CC B, CC. Okay, so you can see that we only use 6 occurrence of C, right? Because that's actually the maximum number of C that we can use in this example. Why? They say that S does not contain any of AAA, BBB, or CCC, right? So in the beginning, right, let's say if I'm being greedy and I want to reduce this guy to 0 as fast as possible, the maximum that I can do is actually append 2C here, right? So that makes this guy 5. Now can I do another 2C? No, right? Because it will violate the rules. I need to have a delimiter. I need to use the guy with that hasn't been used before, right? So let's say that I will take these guys. Now I put A here, right? Okay, so now I here, and I'm being greedy again, and I see that this guy is actually at 5. Now I'm going to put 2C here, which reduce this guy to 3, right? So now okay, I cannot put another 2C here, right? I have to have a delimiter to reset the state of C. Now I'm running out of A. I'm going to put B here, right? After that I can put another 2C here, but now I'm running out of A and B. The only thing that I can do here is to put another C here, right? But I cannot do that. It will make our result to contain CCC, which violate the rules. So right now I hope that you guys can see the pattern. It's actually a heap queue problem, right? A priority queue problem contained with greedy algorithm. We are going to always going to get the character with the maximum frequencies, and then we are going to actually need to check the last letter of the result if it is equal to the one that we're just popping out, right? We are going to pop it again, pop another character from the heap, and then we append it into the queue, right? So let's take a look at this example. For example, if we have 2 occurrence of A and 4 occurrence of B, we need to return the maximum longest possible happy string, right? So now I'm being greedy. I'm going to append 2B here, right? And now that will make this guy 2. Let's say this, we have 5, right? Okay, we have 5, we append 2 here. Now we have 3, right? Now we are going to pop this guy out of the priority queue again, right? Simple, because he's at 3, which is larger than 2. but we do a check. Now we see B, here's B, we just pop out B, and the last occurrence is B also, which tell us what? Now you cannot put in another B into here, so just keep popping out another element. Now it's A, right? Now A has a frequency of 2, but do we append 2A here? We can, right? Basically we can, but actually if we append 2A here, now the next thing we are going to do is that since we don't have any A left, we are going to just append 2B here, and that is a string of length 6, right? But if we append only 1A here, what will happen? If we append 1A here, we have 1A left in the queue. Now if we keep popping out, we're going to append 2B here, right? Now that will make B has the remaining frequency of 1. Now we're going to pop A out and put him here, and then we pop another B. That makes the frequency 7, and that's the longest happy string, right? So there are actually 2 options. The first thing that we're going to pop out the queue is actually different than the last character of the string. We are going to be greedy, and we're going to be to like actually like append as much character of that string into the result as possible. But if it's option 2, if the first thing that we're going to pop out the queue is actually the same, right? The same as the character that we the last character of the result. We're going to pop another guy out the queue, right? And then we're going to be like really use it sparingly. We're going to append just one of that character into our result. Mày cần dùng máy à? Mày cần dùng máy à? Okay. So I hope it makes sense now. What we are going to do is that we are going to create a queue, right? That's just like this. And we're going to hipify. We're going to create the result, and then we're going to say yq, right? And then we're going to pop a guy out the queue, the guy with the largest frequencies, right? Okay, so let's say the frequency and then the character is equal to hip pop q, like so. There are 2 options here. If character is if result, which is equivalent to the result is not none, right? If result and character is equal to result minus 1, what we are going to do is that we are going to say that if q, right, which means if we have another guy in the queue, right, what we are going to do, let's say that if it's the other way around, then if we don't have anything in the queue, right, we're just going to return result because we don't have any option left, right? Let's say that next frequency, next character is equal to hip hop q, right? And then we're going to use it sparingly, right? Let's say result go to next character min 1 and then minus next frequency, right? Is that correct? I think yes. Okay. Because why? Because why why do we need to do this? Why don't we just return like this? Because if you look at the example, because there's actually cases where A, B, or C can be 0. We need to do this, right? Okay, so now what is the leftover, what is the remaining frequency? Once we're doing this step, then the remaining frequency would be actually if next frequent loss, right, plus min 1 minus next frequency is actually not 0, right? We are going to just push it into the queue again. Let's just copy this. And then this next character. Right? Okay. So don't forget to push this guy into queue. Right? We pop him out, but we don't use it. We need to push him into the queue. Right? Hit Q, hit push, Q. Here. Okay. Okay, so that's one option, right? Else, what if the character that we're just popping out is different than the last character of result, or if the result is none? What we are going to do is that we're going to be really greedy, right? What we're going to do is that we're going to say that result plus equal to character min 2. We're going to take 2 character out because he is actually like the guy with the highest frequencies. So we're just going to be greedy and just append as much number of that character as possible, right? Minus frequency, and then we're going to do the next, basically the same step as this, right? If frequency plus min 2 minus frequency is not 0, which means we don't use up all of the frequencies, right? We hit Q, hit push, Q, frequency plus min 2 minus frequency, and then character, and that's it, and just return result here. I hope I don't make any typo. Okay, I do. Okay, submit it. What the hell, why it's so slow? I don't know. I'm telling you guys, it's actually really very efficient. Let's take a look. It's basically the same code, right? Like the IDE of this of Leetcode is actually really bad. Okay, so the time complexity for this is actually O(n) log of n, or you could say O3n 3n log n, right? And then the space complexity is O(n). Okay, because we are using a heap, right? Okay, that's it for today. I hope that it makes sense to you guys, and see you guys on next video. Thank you for watching.